అందరికీ నమస్తే. మీ అందరికీ తెలిసిందే తెలంగాణ స్టేట్ ఎలిజిబుల్ టెస్ట్ నోటిఫికేషన్ రావడం జరిగింది. అదేవిధంగా అతి త్వరలో ఆంధ్రప్రదేశ్ సెట్ నోటిఫికేషన్ కూడా రాబోతుంది. ఈ తరుణంలో అనేక మంది అభ్యర్థులు మమ్మల్ని ఫోన్ చేసి సెట్ క్లాసెస్ కండక్ట్ చేయండి సార్, లైవ్ క్లాసెస్. సో ఇంకా 2 మంత్స్ టైం ఉంది. దీనికి మేము సీరియస్గా ప్రిపేర్ కావాలనుకుంటున్నాము. గవర్నమెంట్ సెక్టార్లో కాంట్రాక్ట్ నుంచి పర్మనెంట్ అయిన వాళ్ళకి ఎలిజిబిలిటీ కోసం స్టేట్ ఎలిజిబిలిటీ టెస్ట్ కానీ, నేషనల్ ఎలిజిబిలిటీ టెస్ట్ కానీ, సిఎస్ఆర్ లాంటిది పాస్ కావాలి. కాబట్టి వాళ్ళందరూ అడుగుతున్న తరుణంలో కూడా మేము సెట్ కోచింగ్ స్టార్ట్ చేయడం జరిగింది. దానికి మనకు డాక్టర్ గణేష్ గారు, డాక్టర్ కిరణ్ కుమార్ గారు, సతీష్ గారు, డాక్టర్ వినోద్ జేఎన్టీయు. సో గణేష్ సార్ ఎన్ఐటి హిమాచల్ ప్రదేశ్, కిరణ్ కుమార్ గారు ఐఐటిఎం నుంచి మనకు సపోర్ట్ చేస్తూ ఉన్నారు. సో అదేవిధంగా మనకు ఆల్జిబ్రా, లినియర్ ఆల్జిబ్రా, కాంప్లెక్స్ అనాలిసిస్, ఓడిఈ, పీడిఈ, మిగతా సబ్జెక్టులు అన్నిటితో పాటు ఇంటిగ్రల్ ఈక్వేషన్స్ కూడా ఈసారి చెప్పించడం జరుగుతుంది. సో మంచి మెటీరియల్, క్వాలిటీ మెటీరియల్తో పాటు నిష్ణాతులైనటువంటి అధ్యాపకుల చేత కోచింగ్ ఉంటుంది. కాబట్టి ఆలోచించకుండా మీరు జాయిన్ కావచ్చు. లైవ్ క్లాసెస్తో పాటు రికార్డింగ్ క్లాసెస్ ఫెసిలిటీస్ కూడా ఉంటుంది. ఎగ్జామినేషన్స్ కూడా కండక్ట్ చేయడానికి ఆస్కారం ఉంటుంది. డౌట్స్ లైవ్ క్లారిఫికేషన్, లైవ్ లోపల మీకు డౌట్స్ క్లారిఫికేషన్ ఉంటుంది. ప్రీవియస్లో అడిగినటువంటి గేట్ సిఎస్ఐఆర్ క్వశ్చన్స్తో పాటు టీఎస్సెట్, ఏపీసెట్ క్వశ్చన్స్ కూడా క్లాస్ రూమ్లో డిస్కస్ చేయడం జరుగుతుంది. ఇంజనీరింగ్ కళాశాలలో ఉన్నటువంటి అధ్యాపకులకు కూడా స్టేట్ ఎలిజిబుల్ టెస్ట్ చాలా అవసరం. కాబట్టి మీ అధ్యాపకులకు ఇన్ఫర్మేషన్ పాస్ చేస్తారని ఆశిస్తున్నాము. ఈరోజు స్టాటిక్స్ 3rd క్లాస్ డాక్టర్ గణేష్ గారు 3rd లెక్చర్ స్టార్ట్ చేయబోతా ఉన్నారు. So I request Dr. Ganesh sir, please start the lecture number 3, probability and statistics. Thank you, sir.
2019 June. Yes, sir. June 2019 question. So, మన డెన్సిటీ ఫంక్షన్ గురించి మాట్లాడుకున్నాం కాబట్టి దాని నుంచే క్వశ్చన్ వచ్చింది. సింపుల్ గా ఏంటంటే the function f of x defined as f of x is equal to c into e power minus x power 4, where x is your real. For what value of c is f a probability density function? So option A 2 by gamma 1/4. Option B 4 by gamma 1/4. Option C 3 by gamma 1/3. Option D 1/4 gamma 1/4. మీరు ట్రై చేస్తారంటే చేయండి. ఒకసారి నాకు ఆన్సర్స్ కూడా చాట్ బాక్స్లో పంపించండి. మీరు కన్ఫర్మ్గా ట్రై చేయాలి. ట్రై చేయకపోతే కష్టం. Consider f of x is as a function of this one. F of x is function of c into e power minus x power 4. So at what value of c, so that this given function is a density function. So I'll give the hint here, clue. We know that integral minus infinity to plus infinity f of x dx must be equal to 1. Means that the total probability is equal to 1. Based on that, you can find out the value of c here. What will be the value of c? Easy question, very simple question. Three marks question has been asked in this. It is June 2019. Okay, June 2019 has been asked. Very simple. At what value of the C, it is a density function. Simple ga try cheyandi. I will wait for your answer. So ikkada manaku we know that minus infinity to plus infinity f of x dx is equal to 1. That we know. This implies so integral minus infinity to plus infinity, because x belongs to here is r. So minus into plus infinity c into e power minus x power 4 dx must be equal to 1, right? So I'll write this one to c integral 0 to infinity e power minus x power 4 dx is equal to 1. So let's put x power 4 is equal to y. So here, or else you can say y is equal to, sorry, x is equal to y power 1 by 4. Then dx is equal to 1 by 4 y power minus 3 by 4 dy. Okay. So this I can write here to c integral 0 to infinity. So in integrals limits won't be changed here. So e power minus y 1 by 4 e power, sorry, y power minus 3 by 4 dy is equal to 1. Okay. So this will be c by 2 integral 0 to infinity e power minus y power minus 3 by 4 dy is equal to 1. So if you remember this one, okay, if you remember this one, integral 0 to infinity, if you know that integral 0 to infinity e power minus x power n dx is gamma of n plus 1, right? So if you know that, this I can write c by 2 gamma of minus 3 by 4 plus 1 is equal to 1. So this I can write c into gamma of 1 by 4 is equal to 2. This implies c is equal to 2 by gamma of 1 by 4. The right answer is A. Got it? Any doubt in this? Which is simple question. No tricky, nothing is there. Very simple question. Just you have to find out the value of C, provided it is a density function. మనకు density function కావాలంటే first condition ఏంటి? అది equal total probability equal to 1 angle. అంటే integral because of the density, we'll write integral minus infinity plus infinity f of x dx is equal to 1. If it is a discrete, so we can define the range, a discrete one, summation over the range p of x is equal to 1. That I have already written in the discrete case, that summation P of x is equal to 1 all the time. Let it be summation over n. N ranging from either you can say. Okay. We'll go for another question. But this is a recent question only. It is asked in June 2023. Sorry, June 2023 CSIR. The question is, if f of x is probability density function on real line, then which of the following is not a valid probability density? What does that mean? Which is not a probability density function? Option A, f of x plus 1. Option B, f of 2x. Option C, 2 into f of 2x minus 1. Option D, 3x square f of x cube. You can try. Here also same hint. Integral minus infinity plus infinity f of x dx should be equal to 1. Means that you have to check this function, this function, this function, and this function. Okay? So try. Try and post the answers.
టూ ఎక్స్ ని వై అనుకుంటే వస్తుంది సార్.
2x ని
సమ్ వై అనుకుంటే ఇందాకట్లాగా
ఓకే
2x is equal to y, then 2
Hmm.
dx is equal to dy అవుతుంది. dx is equal to 1 by 2 dy. So integral minus infinity to plus infinity f of 2x dx is equal to 1 by 2 integral minus infinity to plus infinity f of y dy.
f of y dy.
So 1 by 2 into 1 by 2.
Hmm.
So but it
1
should be
by 2.
equal to 1 కాబట్టి
Correct. Correct.
it's not a density.
Density function.
Yes.
So remaining all three are density functions.
First one is density functions. Same if we consider x plus 1 is equal.
మేడం మీ వాయిస్ స్లో వస్తుంది మేడం, ప్లీజ్.
First the A option is density functions.
Yes.
Second.
What about third and fourth?
I didn't check, sir. I have to check. I will check.
Actually, in net examination, you should check other options also, because there may be a chance of multiple options. You should remember, if the question is in part B, then you may have only one option. If it is in part C, definitely more than one options will be there. But in 2022 and 23, if you observe, there is no specific section like that, part B and part C like that. They are asking direct questions. They have not mentioned anywhere. ఇది పార్ట్ సిలో ఉంటుంది, ఇది పార్ట్ బిలో ఉంటుందని ఎక్కడ మెన్షన్ చేయలేదు. సో అందువల్ల మనము కన్ఫర్మ్ గా క్రాస్ చెక్ చేసుకోవడం మంచిది. మీ ఫస్ట్ క్లాస్ నుంచి కూడా అబ్జర్వ్ చేస్తే మనం 2023లోనే ఎన్నో క్వశ్చన్స్ వచ్చినాయి చూడండి ఒకసారి. నక్షత్ర ఆప్షన్ సి. వై ఇట్ ఈస్ ఆప్షన్ సి? See, for first option A, y is equal to x plus 1. What does it mean? X is equal to y minus 1. Or simple, it is y only. It's a constant. So, integral minus infinity to plus infinity, f of x plus 1 dx. I can write integral minus infinity to plus infinity, f of y dy. It is equal to 1. Okay? It is a density function. Right? So coming to the second one, put 2x is equal to y. Okay? Or x is equal to y by 2. So can I write integral minus infinity to plus infinity, or you can write is dx. This implies dx is equal to dy by 2. So f of 2x dx is equal to, we'll write integral minus infinity to plus infinity, f of y dy by 2. What does that mean? 1 by 2 integral minus infinity to plus infinity, f of y dy. It doesn't mean 1 by 2 into 1, that is 1 by 2, which is not equal to 1. So this is not a density function. Okay? So coming to the third one, put y is equal to 2x minus 1, so that x is equal to y plus 1 by 2. So these are all the constant. You can say simple, it's a y, which means 2 into integral minus infinity to plus infinity. There is a 2 into, it has written 2 into f of 2x minus 1. So f of 2x minus 1 dx. So this is equal to, you can say it's a dx is equal to, what you can get, 1 by 2 into dy. So it is 2 integral minus infinity to plus infinity, f of y dy by 2. So 2 will cancel. Then it will come as integral minus infinity to plus infinity, f of y dy. This is equal to 1. It is also a density function. Coming to the last one. You can put x cube is equal to y, so that 3x square dx is equal to dy. So what is the given function? 3x square f of x cube. So I can write 3x square f of x cube. How I can write this one? So integral minus infinity to plus infinity, 3x square f of x cube dx. I can write this one, integral minus infinity to plus infinity
y dy.
So 3x square, or you can say dy by 3x square dx is equal to, you can write f of y, it is a 3x square here, sorry, 3x square f of y dy by 3x square. So I can say this is also integral minus infinity to plus infinity, f of y dy, which is also a density function. So Only option B is the right answer, because which is not a valid probability density. Okay. I'll give a homework for you people. Let's check. This is also asked in CSIR 2023 only. Okay. June 2023, it is asked. Question is, which of the following is a valid cumulative distribution function? It has not mentioned that whether it is a discrete or whether it is a continuous. Simple, it has been given that which of the following is a valid cumulative distribution function. Option A has given capital F of x is equal to 1 by 2 plus x square if x is less than 0, 2 by x square by 3 plus x square if x is greater than or equal to 0. I'll write option B here. So f of x is equal to 1 by 2 plus x square if x is less than 0, 2 plus x square by 3 plus 2x square if x is greater than or equal to 0. Then option C, capital F of x is equal to 1 by 2 plus x square if x is less than 0, 2 cos x plus x square upon 4 plus x square if x is greater than or equal to 0. Here I'll write D. Option D is capital F of x is equal to 1 plus 2 plus 1 by 2 plus x square if x is less than 0, 1 plus x square upon 4 plus x square if x is greater than or equal to 0. I'll give a hint of this one. So distribution function at the first time avali f of minus infinity 0 avali, f of infinity 1 avali. This is first condition. Second condition vachesi f is non-decreasing monotone. F is non-decreasing monotone. Means that f is a increasing function. F is increasing function. As simple you can say here, if f is less than, yes, you can see f is equal to x is equal to 0. F of 0 here, it is 1 by 2. and here is, it's a 2 by 3. So if it is a continuous, it must be the same. At 0 value, it must be the same. But it is a simple, you can say it is your distribution function is discrete one. Means that your x is a discrete random variable. Okay. So you can solve, and this is a homework for you people. Okay. So we'll go with two-dimensional random variables. Means that so far we have discussed about only one-dimensional random variable. Now we can go with two-dimensional random variables, or you can say joint probabilities. Means that joint probabilities and marginal probabilities. We are going to discuss joint probability, marginal probability. And because of the two variables are involving is there, maybe you can go at conditional probability density functions or conditional probability mass functions. You can say conditional probability mass functions or conditional probability density functions. Okay. First, we'll define what is joint probability mass function, and after that, we can go with joint probability density function and marginal probability mass function and marginal probability density functions, and then conditional probabilities and all. First, we'll define first. Okay. First, we define simple. Let x and y are two random variables. Okay. Two random variables on sample space S. Okay. With respect to that, this has an image of x of S is equal to, you may have x1, x2, and so on, xn. And this is image of y1, y2, and so on, yn. Then the product space, that is x of S into y of S. What does that mean? x1, x2, xn into y1, y2, and so on, yn. So it will be the pair. Okay. Or simple, I can say xi comma yi, or xi into yi, or maybe you can say it is probability of x is equal to xi comma y is equal to yi. So this can be written as p xi comma yj, or you can say pij here. Okay. Just simple. We are writing probability of x is equal to xi in discrete case of one-dimensional random variable. One-dimensional random variable. If two-dimensional, we'll write probability of x is equal to xi comma y is equal to yj. So if you write this one is p of xi, and this we can write p of xi comma yj, or you can say it is I comma j. Simple. It's very defining it is simple because you have only two variables. means that bivariate probability mass function. Okay, it's a bivariate probability mass function. So definitely the same properties will be hold here. What is the properties of that one? Because of one in single random variable, we'll write summation P of xi must be equal to 1. You can say I ranging from 1 to n here. If it's a two-dimensional random variable, we'll write summation I ranging from 1 to n, summation j ranging from 1 to n, probability a xi comma yj must be equal to 1 because of the joint probability. You are going to find out joint probability distribution function of two random variables x and y. Okay, so from this joint you can find out the marginal, means that you can draw. So from that, how you can draw this one, or how you can define marginal from this joint? Simple. See, we'll write like px of xi. So that is probability of x is equal to xi. You should draw from this one. You should draw from probability of xi comma yj. Is that, sorry, not p ij. You have to draw from joint probability distribution function. So this I can write. Can I write this one? Probability of x is equal to xi intersection y is equal to y1 plus probability of x is equal to xi intersection y is equal to y2 plus and so on, plus probability of x is equal to xi intersection y is equal to yj plus and so on, plus probability of x is equal to xi intersection y is equal to ym. So can I write this one? Pi1 plus Pi2 plus Pi3 plus and so on, plus Pij plus and so on, plus Pim. What does that mean? Pi1 is simple. This one, sorry. Pi1 is probability of x is equal to xi intersection y is equal to y1, or simple you can write probability p xi comma y1. Simple, this is the one. This is I1 p xi comma y1. So can I write this one? Summation j ranging from 1 to m Pij, or else you can write summation, sorry, j ranging from 1 to m P xi comma yj, and this I can write, let be Pi dot. What does it mean? Pi dot means it is a marginal probability function of x. It is a marginal I dot. It is a marginal probability function of x. Similarly, marginal probability function of y. How you can write marginal probability function of y? Simple. This is probability of, sorry, you can write px xi. This will be. And if it is, you can write p y yj. Simple, you can write summation I ranging from 1 to n p xi yj, ij here, is equal to, you can write p dot j. This is marginal probability function of y. Simple, you can remember, if you are finding or you are writing the marginal function of you are writing the marginal function of x, which means the summation should be y. If it is a y, the summation should be for x. Simple. Then coming to the condition, because of the 2 means that you have A and B, which means you are having A intersection B, or you can say AB. What does that mean? Probability of AB is nothing but probability of A intersection B. Both are same. Okay. So AB, so if they are independent, we can write directly. If they are not independent, then conditional probability will come into the picture. మనకు మల్టిప్లికేషన్ థీరంలో మీకు గుర్తుంటే మల్టిప్లికేషన్ థీరంలో మనం ఏం రాసేటాం? ప్రాబబిలిటీ ఆఫ్ A intersection B is equal to probability of B given A into probability of A, or probability of A given B into probability of B. Here provided probability of A is not equal to 0. Here is probability of B is not equal to 0. Okay, or else you can write probability of A given B is equal to, how you can write? Probability of A intersection B upon probability of B, or probability of B given A, will write probability of A intersection B upon probability of A. This is the conditional density. Okay, if A and B are independent, what does it mean? If A and B are independent, probability of A given B will be probability of A only, because there is no condition in that. The similar way here also, probability of B given A, if B and A are independent, you can write this as probability of B, simple, because it doesn't have anything, which means probability of A intersection B, if A and B are independent, you can write probability of A into probability of B. If A and B are independent, we have not written here because of the two random variables. Because of the two random variables, we don't have any information. మన దగ్గర ఏ ఇన్ఫర్మేషన్ లేదు. అవి ర్యాండమ్ వేరియబుల్ x, ర్యాండమ్ వేరియబుల్ y అనేటివి ఇండిపెండెంట్ డిపెండెంట్ అని. ఒకవేళ ఇండిపెండెంట్ అయితే కండిషనల్ ప్రాబిలిటీ ఎగ్జిస్ట్ అవుతుంది, అంటే కండిషనల్ డిస్ట్రిబ్యూషన్ ఫంక్షన్ ఎగ్జిస్ట్ అవుతుందని మీనింగ్. అట్లా అర్థమైందా? కండిషనల్ డిస్ట్రిబ్యూషన్ ఫంక్షన్ ఎగ్జిస్ట్ అవుతుంది. సో అందువలన మనము కండిషనల్ డిస్ట్రిబ్యూషన్ ని ఎలా డిఫైన్ చేస్తాం? యూజింగ్ మల్టిప్లికేషన్ థీరం ఓన్లీ. దెర్ ఇస్ నో అదర్ ఆప్షన్ ఫర్ us. It is simple. Using multiplication theorem, the probability of x is equal to xi given y is equal to yj. You can write this is A and this is B. ఎలా రాస్తాం మనం? A given B, probability of A intersection B upon probability of B. Correct? దీన్ని నేను ఇలా రాసుకోవచ్చా? probability of x is equal to xi comma y is equal to yj upon probability of y is equal to yj అని రాసుకోవచ్చా? సో దీన్ని నేను Pij upon P dot j. This is probability of x given y. ఇది similarly probability of y given x ఎలా రాసుకోవచ్చు నేను? కండిషనల్ డెన్సిటీ, సారీ కండిషనల్ డిస్ట్రిబ్యూషన్ ఫంక్షన్ Pij, it's a common, then you can write here pi dot pi dot. ఇక్కడ కండిషనల్ డెన్సిటీలో కండిషనల్ డిస్ట్రిబ్యూషన్ ఫంక్షన్ లో కూడా ఫర్ ఎగ్జాంపుల్ if you have y given x is equal to xi, or you can say, let it be also, you can write summation I ranging from 1 to n pij upon p dot j. ఏమవుతుంది ఇది? which means p1j plus p2j plus and so on plus pij plus and so on plus pnj upon p dot j. దీన్ని ఎలా రాయొచ్చు? ఇది న్యూమరేటర్ అని మనం can I write p dot j, this is also p dot j, which is equal to 1. Similarly, summation j ranging from 1 to m pij upon p I dot, which is also equal to 1. సేమ్ మల్టిప్లికేషన్ థియరంలో చెప్పుకున్న మాదిరిగానే మనకు మల్టిప్లికేషన్ థియరంలో చెప్పుకున్న మాదిరే 2 random variables x and y are independent. x and y are independent అయితే ఏమవుతుంది మనకి ఇక్కడ? probability of x is equal to xi, y is equal to yj. ఎలా రాసుకోవచ్చు అంటే probability of x is equal to xi into probability of y is equal to yj. Okay, means that your joint distribution function is the product of two marginal distribution functions if x and y are independent. Your joint, means that you can write the joint distribution function will be product of two marginal distribution functions, little bit, provided x and y are independent. Okay, x and y are independent. Otherwise, they are said to be dependent. So, ఇది మనకు distribution function. It is a discrete case. If it is a continuous case, how I can write continuous case? So, whatever I have written, because of the summation I have written is a summation. It means that it's a discrete case. If it is a continuous case, how I can write? Simple. Instead of summation, I can write a integration. Means that fxy x comma y, which means probability of minus infinity is less than x is less than or equal to x, comma minus infinity less than y is less than or equal to y. ఎందుకు ఇలా రాసుకున్నాం? Hope you remember, in one dimensional random variable, capital f of x is probability of x is less than or equal to small x ante, which means it is integral minus infinity to x f of u du, like that we write. Hope you remember. So ikkada nenu em raskuntanante idi integral minus infinity to x, దీనికి ఇది integral minus infinity to y. So because of the joint density, f of u comma v, you can write uv here, du dv. So as usual, ఇది డెన్సిటీ అంటే జాయింట్ డెన్సిటీ కాబట్టి మనం కన్ఫర్మ్ గా f of x, y must be greater than or equal to 0. Okay, and total joint density, sorry, dx should be equal to 1. It is a continuous case. If it is a discrete case, we can write summation over x, summation over y, p xy must be equal to 1. Okay, same ఇది ఇప్పుడు మనకు వన్ డైమెన్షనల్ ర్యాండమ్ వేరియబుల్ లో ఫంక్షన్ నాన్ డిక్రీజింగ్ మోనోటోన్ అని చెప్పాం. ఏది డిస్ట్రిబ్యూషన్ ఫంక్షన్ నాన్ డిక్రీజింగ్ మోనోటోన్ అని చెప్పాం. సో అలాగే ఇక్కడ కూడా 2 డైమెన్షన్ లో కూడా ఇది నాన్ డిక్రీజింగ్ మోనోటోన్ ప్రాపర్టీస్ లోకి వెళ్తే. సెకండ్ థింగ్ మనం ఇంపార్టెంట్ ప్రాపర్టీ ఇక్కడ మనం ఏం చూసుకోవాలంటే f of minus infinity comma y is equal to 0, which is f of x comma minus infinity. Okay, or else second this one you can write f of infinity comma infinity is equal to 1. Hope you remember, f of minus infinity is equal to 0, f of infinity is equal to 1 in one dimensional random variable. One dimensional random variable. Got it? If it is a density function, means that x and y are continuous random variable, if the distribution function is defined, then second derivative of your distribution function will be joint density function. So in one dimensional random variable, what do you write? This is the extension of this one. Okay, in one dimensional random variable, we'll write simple. It is like this one. So now we'll write joint density function. Joint density function. We have discussed the joint marginal and joint joint distribution and joint with respect to continuous, with respect to continuous and with respect to discrete. Now we can go with joint density function. Okay, or here we can write conditional density also, or conditional distribution function, sorry, conditional distribution function when it is a continuous case, which means, or you can write it's in a marginal distribution function in a continuous case. What you can write? F of fx of x is it, which is probability of x is less than or equal to x. What does that mean? Probability of x is less than or equal to x, comma y is equal to y. Sorry, y is less than infinity, or you can say y is less than infinity, or you can say it is limit y tends to infinity fxy x comma y, or I can write this one fxy x comma infinity. It is marginal distribution function, continuous case, marginal distribution function, and the marginal distribution function of x. And similarly, marginal distribution function of y, will write probability of y is less than or equal to y, which is probability of x is less than infinity, sorry, capital X less than infinity, y is less than or equal to, y is less than or equal to small y, which I can write fxy infinity comma y. So this is the marginal distribution function of x and distribution function of y. Okay. If it is a discrete case, this I can write probability of x is less than or equal to x comma y is equal to y, and this I can write in a discrete case probability of x is equal to x comma y is less than or equal to, sorry, capital Y is less than or equal to small y. Okay. You should remember here, in continuous case, your marginal distribution function, which is integral minus infinity to x, integral minus infinity to plus infinity, fxy, x comma y, dy into dx. Because this is minus infinity to plus infinity with respect to x. And with respect to y, marginal distribution function of y is integral minus infinity to y, integral minus infinity to plus infinity, fxy, x comma y, dx into dy. Now coming to the conditional distributions. Conditional distributions. Probability of x given m, let it be. M is a conditional probability, this one. Or I can write probability of x is less than or equal to x given m. This I can write probability of x is less than or equal to x comma m upon probability of m. And the property of this here, f of infinity given m is equal to 1 and f of minus infinity given m is equal to 0. And the same property, hope you remember, probability of x1 is less than, capital X is less than or equal to x2 given m is f of x2 given m minus f of x1 given m. Hope you remember, in one-dimensional random variable you have written probability of a is less than, x is less than or equal to b. We have written f of b minus f of a. Okay. In a similar way. In a conditional density, simple. Even in conditional density function, you can write x given m. Maybe you can derive with respect to x because x marginal density function of x, conditional density of your distribution conditional distribution function, and derivative with respect to x, you can get the conditional density function. So let me an example. You can take an example of this one. Let fair die. Okay. The same example what we have taken in the define of random variable. Let m is your even numbers, f2, f4 and f6, means that casting a die. Okay, casting a die, your conditional is even numbers and your random variable is 10 into I. Random variable is 10 into I. So f x given m is, it is 1 for every x is greater than or equal to 60. It's 1/3 for every it is 40 less than or equal to x is less than 60. It is 1 by 3 for every 20 less than or equal to x is less than 40. It is 0 for every x is less than 20. X is less than 20. What does that mean? So you can take this one, which means f of x, here x is greater than or equal to 60 given m. So probability of x is greater than or equal to 60 comma m upon probability of m. Okay, this is the one. Greater than or equal to 60 given that they are the even numbers, that is f4, sorry, f2, f4, f6, upon f2, f4 and f6. So this is 1 because it's, you can get it is 1 by 2, and this is also 1 by 2, means that 3 by 6 by 1 by 2. So 3 by 6 by 1 by 2, you can get 1. Means that number of samples in greater than 60 comma the joint common intersection points in 60 comma your even numbers, they are same given by your even number. So that is correct. And second one, this one, for this one, probability of 40 less than or equal to x is less than 60 comma m upon probability of m. Which means probability of 40 comma, okay, f2, f4, f6. Why I have not taken 50? Because only even numbers upon probability of m. Okay, no problem. So what is the common with this one? It is f4 only upon f2, f4, f6. This is 1 by 3. Means that it is f4, it you can get you can get 1 by 6 upon 1 by 2, that is 1 by 3. Okay. So similar way, this is also. It is also you can get f2 upon f2, f4, f6 you can get. This is also your 1 by 3. Strictly less than 20. There is no number less than 20 in the conditional. So definitely your answer will be 0. Okay. So now joint density function and marginal density functions. Joint density functions and marginal density functions. Simple, as I have written there, I can get from my distribution function in a continuous case, I can get my joint density function from the distribution function. If I know distribution function for continuous case, I can draw my joint density function by derivating, partial derivating with respect to x and y. What about the marginal one? Is that fy of y, that is integral minus infinity to plus infinity fxy x comma y. If you integrate with respect to x, you can get marginal one, or it's in a discrete case, summation over x pxy x comma y. This is continuous case and this is discrete case. Okay. And similarly, sorry, f x of x, you can write integral minus infinity to plus infinity fxy x comma y dy summation over y pxy x comma y. So this is discrete case and this is continuous case. Simple. If you want to find out the joint, if you want to find out the marginal one from the joint, then just you can opposite variable, you can integrate opposite variable, you can get the original one. It is the same summation over y, you can get px of x here. Okay. If it is summation over x, you can get py of y here. Got it? Important property you can remember. If we know the joint probability mass function, or probability density function fxy x comma y of two random variables, we can obtain the individual distributions of x and y. Is that x and y in the form of marginal functions, marginal PDF bar PMF. However, converse is not true. Converse is not true, which means మనకు జాయింట్ డెన్సిటీ ఫంక్షన్ ఉంటే దాంట్లోంచి మార్జినల్ డెన్సిటీ ఫంక్షన్ కానీ మార్జినల్ డిస్ట్రిబ్యూషన్ కానీ మనం డ్రా చేసుకోవచ్చు. అలానే మన దగ్గర 2 మార్జినల్ ఫంక్షన్స్ ఉన్నాయి, నేను జాయింట్ అని అనుకుంటున్నా అంటే కుదరదు. ఎందుకంటే జాయింట్ అనేది ఒక సెట్ ఆఫ్, యూ కెన్ సీ, నేను డయాగ్రామ్ వేసి చూపిస్తాను ఇక్కడ. Okay, simple. We are finding the density. This is, let it be, this is y axis, this is z axis, this is x axis. Just we are concentrate on this density. Concentration on this density. If you see in this one, okay, or else you can make it, this is x-axis, this is this is x-axis, this is y-axis, and somewhere else it is your z-axis here again. Okay, so this is the right one. We are trying to make this one is fxy x comma y. Okay. Conditional densities kuda same మనం ఇలాగే find out చేసుకోవచ్చు. Conditional distribution function, conditional density function also. Okay. Conditional distribution function and conditional density function. Conditional distribution already మనం చెప్పాము. ఇప్పుడు conditional density కి just formulas రాసిస్తాను అంతే. మళ్ళీ ఎక్కువ డిస్కషన్ అవసరం లేదు. How we can write f y given x, we can write partial derivative with respect to y of your distribution function y given x. Simple. Okay. లేదా జాయింట్ డిస్ట్రిబ్యూషన్ ఫంక్షన్ లోనే మెన్షన్ చేయాలనుకుంటే కనుక ఎలా రాసుకోవచ్చు అంటే దీన్ని fxy x comma y, we can write integral minus infinity to x f y given x your distribution function with respect to x. Okay. Similar way, integral minus infinity to x f x given y dy of y. ఓకే, ఈవెన్ మనం ఇంతకుముందు దీంట్లో కండిషనల్ ప్రాబిలిటీ డెన్సిటీలో చెప్పుకున్నట్టు ఎఫ్ వై గివన్ ఎక్స్ ఎఫ్ xy అపాన్ fx ఆఫ్ x. మీరు ఇది గమనిస్తే f of, or you can say it's a probability of a given b is equal to probability of ab upon probability of b. సేమ్ ఇలాగే లేదా? ఓకే. సో అందువల్ల మనం దీన్ని ఎక్కువ కాన్సన్ట్రేషన్ ఏం చేయట్లేదు. ఓకే, సో కండిషనల్ డెన్సిటీలో కూడా స్టొకాస్టిక్ ఇండిపెండెన్స్ అనేది ఒకటి ఉంటుంది మనకు. ఎక్కడ ఇండిపెండెన్స్ అవుతుంది అనేసి stochastic independence. Let us consider two random variables of x and y, whether in discrete case or continuous case, whatever it may be, and then joint probability density function and the marginal density functions. Okay, so we can write x and y are two random variables. They have the joint probability density function f xy x comma y and marginal density functions fx of x and gy of y. These are the marginal density functions. Okay. Then the compound theorem. And the compound theorem says, or that by compound theorem, fxy x comma y, we can write fx of x into gy of y given x, where y given x is a conditional probability density function of y given the value x is equal to x. You can write here, it is a conditional probability density function of y given x is equal to x here. At x is equal to x in continuous case, it won't have any meaning in that. Okay. So, ఇక్కడ stochastic independence అంటే simple. G of y given x, if you write simple G of y, what does it mean? It is a stochastic independence. What does it mean? Which is not depend upon x. Or simple, you can write independent random variables that we have written in the independent random variables, that if fxy x comma y is equal to, I can write fx of x into fy of y. Okay, independence. Let I will solve one problem on this. ఇలాంటి క్వశ్చన్ మీరు ఎక్స్పెక్ట్ చేయొచ్చు. ఎగ్జాంపుల్, 2 discrete random variables x and y have the joint probability mass function. Have the joint probability mass function P x comma y is equal to lambda power x e power minus lambda p power y 1 minus p whole power x minus y upon y factorial into x minus y factorial, where y is equal to 0, 1, 2 and so on x, and x is equal to 0, 1, 2 and so on, where lambda p are constants with lambda greater than 0, and it is lies between 0 and 1. Basically, our p is lies between 0 and 1. So can you find the marginal probability density, probability mass functions of x and y? And second one, the conditional distribution of y for a given x and of x for a given y. Okay, So conditional function y given x and x given y we have to find out. And then so we go with the solution here. What will be the solution? So first we have to find out marginal mass function with respect to x. Summation over y ranges from 0 to x, p xy. What does it mean? Summation y is equal to 0 to x. Pxy is lambda power x e power minus lambda p power y into 1 minus p whole power x minus y upon y factorial into x minus y factorial. So here lambda power x e power minus lambda by x factorial. You can take a constants these are because you don't have any y variable in this. And then you have, you can make here, it is a x factorial. Just you are multiplying with x factorial here. P power y 1 minus p power x minus y upon y factorial into x minus y factorial. Just I am taking here from 1p outside and then you can get it is here. P power y is there. So this I can write lambda power x e power minus lambda by x factorial. Summation y is equal to 0 to x, y ranging from 0 to x. This entire thing, how we can write? xcy p power y 1 minus p power x minus y. Okay. So this entire thing is your binomial distribution. And you can write simple. If it is px of x is simple, you can write e power minus lambda power x by x factorial, because y range from 0 to x, this entire thing will be 1, where x is equal to 0, 1, 2, and so on. So which is the PMF of Poisson. We'll discuss later Poisson distribution to Lambda. So what about the with respect to y? Py of y, that is summation x ranging from 0 to y, 0 to infinity, p xy. So this I can write summation x ranging from y to infinity. Can I write x is equal to y to infinity? Because y is ranging from 0 to x, right? Lambda power x e power minus lambda p power y minus 1 minus p whole power x minus y upon y factorial into x minus y factorial. So this I can write simple. Lambda power x, and here I can send it to the, let it be, I can write like this. Let it be lambda p whole power y e power minus lambda by y factorial summation x ranging from y to infinity. Can I write like this? Lambda into 1 minus p whole power x minus y upon x minus y factorial. This simple. Lambda power x minus y. So here I can write lambda power y. So here lambda power minus y, lambda power y, it will be 1. Just sample I am taken like this. So here this will be lambda p whole power y e power minus lambda by y factorial. Can I write this one e power lambda into 1 minus p? You can write x is y. Every value of y, you can get exponential function with this. So this one e power minus lambda p power y by y factorial. So this is also a Poisson distribution with parameter lambda p. Okay, with parameter lambda p. So now the conditional distribution function of y. Second one. The conditional distribution of y for given x, which means p y given x. So thus I can write pxy x comma y upon px of x. So that means lambda power x e power minus lambda p power y 1 minus p power x minus y x factorial upon y factorial x minus y factorial lambda power x e power minus lambda. So this is your px of x. Okay. So this I can write x factorial upon y factorial into x minus y factorial p power y into 1 minus p whole power x minus y. Okay. This xcy p power y 1 minus p whole power x minus y for x is greater than y. This is your density, conditional distribution function of, not density, conditional distribution function of y given x. Similarly, x given y, that is pxy xy p y of y, that is lambda power x e power minus lambda p power y 1 minus p whole power x minus y upon y factorial into x minus y factorial into reverse, you can write y factorial e power minus lambda p whole power y. Okay. So directly I can write the answer here. E power, or simple you can write e power minus lambda q whole power x minus y by x minus y factorial. You can write y q is equal to 1 minus p for x greater than y here. Okay, this I can write. Now I can write this given function lambda power x e power minus lambda, okay, p power y, 1 minus p whole power x minus y by y factorial into x minus y factorial into y factorial upon e power minus lambda p power y. So these two will be cancelled and I can get here lambda power x e power minus lambda e power lambda p power y lambda p power minus y 1 minus p whole power x minus y upon x minus y factorial. So this is lambda power x e power minus lambda 1 minus p. This you can write. It is 1 by lambda p whole power y, this one. And this I can write 1 minus p whole power x minus y upon x minus y factorial. Okay. So this lambda power x e power simple lambda power x minus y, or you can write like this lambda power x e power minus lambda into 1 minus p into lambda power minus y. It is 1 minus p whole power x minus y upon x minus y factorial. So this e power minus lambda into 1 minus p lambda power x minus y 1 minus p whole power x minus y upon x minus y factorial. So this I can write e power minus lambda q, where you can write 1 minus p is equal to q lambda q whole power x minus y upon x minus y factorial, where q is equal to 1 minus p and x is greater than y. Okay. So I'll give an example here. Numerical one. If x and y are two random variables having joint density function, that is f of xy is equal to 1 by 8 6 minus x minus y, where your x is lies between 0 to 2 and y is 2 to 4, otherwise it is 0. Your density joint density function is 0. So first you can find out probability of x is less than 1, give intersection y is less than 3. Okay. Second one, probability of x is less than 1 given y is less than 3. Or simple, if you write this one, automatically you have to find out this one also. Okay. We'll solve this one. So first one, probability of x is less than 1 intersection y is less than 3, that is integral minus infinity to 1, integral minus infinity to 3, fxy dx dy. Okay. So it is lower limit at for x value, it is 0 to 1, and it is 2 to 3, 1 by 8, 6 minus x minus y dx dy. So first I can make with respect to y, that is integral 2 to 3, 1 by 8, 6 minus x minus y dy dx. So this will be 1 by 8 integral 0 to 1 6y minus xy minus y square by 2 2 to 3 dx. Okay. So it is 1 by 8 integral 0 to 1. You can make it is 6 into 3 minus 1. 3 minus 2 is 1. Minus x into 3 minus 2, it is 1. Minus y square. So it is 3 minus 3 square minus 2 square. That is 5 by 2 dx. Okay. So this will be 1 by 8. You can find out directly. It is 6x minus x square by 2 minus 5 by 2x at 0 to 1. We are integrating with respect to x here of the rest of the function. And then after you are applying the limits for this one, 1 by 8, 6 into 1 minus 0 is a 6, minus 1 by 2, 1 minus 0 is a 1 by 2, minus 5 by 2, 1 minus 0, it is 5 by 2 again. So you can get it as it is v by 8. So this is your probability of x is less than 1 intersection y is less than 3. So coming to the second one, probability of x is less than 1 given y is less than 3. How we can write? Probability of x is less than 1 intersection y is less than 3 upon probability of y is less than 3. So this we know the value is 3 by 8. So first we have to find out probability of y is less than 3. That is integral 0 to 2, integral 2 to 3. The y is 2 to 3, 1 by 8, 6 minus x minus y dy. Okay, we can make it is here dx. Okay, so it is 1 by 8 integral 0 to 2. It will be 6y minus xy minus y square by 2 2 to 3 dx. This will be 1 by 8 integral 0 to 2 6 minus x minus 5 by 2 dx. This is 1 by 8. You can apply the integration with respect to x. What you can get? 6 x minus x square by 2 minus 5 by 2 x. It is 0 to 2. So it is 1 by 8. 6 into 2 minus 0, 6 into 2, it's a 12 minus 1 by 2 into 4 minus 0. Or you can say it is 4 by 2 minus 2 by 5, 2 will be cancelled, it will be 5. So that you can write 1 by 8, 12 minus 2 minus 5, that will be 5 by 8. So the final answer is probability of x is less than 1 given y is less than 3 is probability of x less than 1 intersection y less than 3 upon probability of y is less than 3. That is 3 by 8 upon 5 by 8. It is, you can get 3 by 5. Okay. So I'll give another question for you like this. I think tomorrow we'll discuss about the transformation of random variables. That is how you can transform from one domain to another domain. Okay, that is one-dimensional and two-dimensional, both we can discuss. There we can use Jacobian transformation for transforming to one variable to another variable. Maybe you can solve this question also. This question homework you can take. Let x and y be jointly distributed random variables. Jointly distribution, okay. Jointly distributed with PDF f of x comma y. It is 1 by 4 1 plus x plus y, where your x mod x is less than 1, 0 otherwise. Okay. Show that x and y are independent. Sorry, x and y are not independent. Sorry. X and y are not independent, but x square and y square are independent. Okay. This you can see. So regarding today's lecture, do you have any doubt? Please let me know.
Yes, thank you. Yeah, please ask your doubts and clarifications regarding to this topic. Anyone మీకు ఇక్కడ ఇంతకుముందు క్లాస్లో కానీ ఇప్పుడే కానీ డౌట్స్ ఉంటే క్లారిఫై చేసుకోండి. మాట్లాడండి సార్ తోటి ఒకసారి. భాగ్యమ్మ మేడం, చంద్రకళ గారు, are you there?
Sir. Yes.
వాయిస్
No, no.
వినపడతలేదు.
No doubts, sir.
నో
It's
డౌట్స్.
clear.
ఓకే, గుడ్.
దెర్ ఆర్ టూ, అంటే రెండు రకాలుగా మనం అనుకోవచ్చు. డౌట్ లేదంటే ఈజ్ ఇట్ క్లియర్, ఈజ్ ఇట్ క్లియర్. కోడ్
Yes.
క్లియర్ మీన్స్ దట్ ఏం అర్థం కాలేదంటే జీరో క్లియర్.
Homework చేస్తే
అంత-
ఒక ఐడియా వస్తుంది, sir.
ఓకే,
Homework
అంత
చేస్తే
అర్థమైంది, అది ఫుల్ క్లియర్.
ఆ,
రెండు రకాల క్లియర్ గా అనుకోవచ్చు మనం. మీకు ఫుల్ గా అర్థమైంటే ఓకే, నో ప్రాబ్లం, వీఆర్ వెల్, అంటే
yeah.
మేము చాలా సాటిస్ఫై అవుతాం, ఎందుకంటే మా
Yes, sir.
ఎఫర్ట్స్ మీకు అర్థం అవ్వడానికే.
అంత రిస్క్ తీసుకొని చెప్తున్నప్పుడు మీరు క్లారిఫికేషన్ ఇవ్వండి, ఎట్లా కావాలంటే అట్లా సార్ రెడీగా ఉన్నారు చెప్పడానికి, అట్లా మేము అడుగుతా ఉన్నాం. మరి దట్స్ ఎందుకంటే ఇంత టైం కేటాయిస్తున్నప్పుడు మీకు రీచ్ అయితే సార్ హ్యాపీ ఫీల్ అవుతాం, మేము కూడా హ్యాపీ ఫీల్ అవుతాం. ఇంకెలా కావాలంటే అలా అందుకోసం మాట్లాడండి ఒకసారి, ఇంటరాక్ట్ కానీ. ఓకే,
No doubt, sir.
నో డౌట్స్. భాగ్యం గారు, రైట్. థ్యాంక్ యూ సార్.
థ్యాంక్ యూ సార్.
ఓకే సార్, థ్యాంక్ యూ.
మనం రేపు ట్రాన్స్ఫర్మేషన్ ఆఫ్ 2 random వేరియబుల్స్ గురించి మాట్లాడుకొని డైరెక్ట్ గా మనం ఇంకా మ్యాథమెటికల్ ఎక్స్పెక్టేషన్ దాని గురించి వెళ్దాం, ఎందుకంటే అక్కడ నుంచి గ్యారంటీగా మీకు క్వశ్చన్స్ వస్తాయి.
సార్
ఇప్పుడు మీకు చెప్పిందంతా ఇదంతా నేను ఇప్పుడు మార్జినల్ డెన్సిటీ ఇవన్నీ చెప్పింది కూడా కన్ఫామ్ గా ఇది బేస్ అనమాట. యాక్చువల్ గా ఇది బేస్ కన్ఫర్మ్, ఇది లేకపోతే మనం ప్రాబ్లమ్ సాల్వ్ చేయలేము. 2 dimensional ర్యాండమ్ వేరియబుల్ కానీ, జాయింట్ కానీ, కండిషనల్ డెన్సిటీ కానీ, ఇవన్నీ మీకు క్వశ్చన్స్ కొన్ని ఉన్నాయి. అవి మీకు ప్రీవియస్ క్వశ్చన్స్ ఎలా అడిగారో కూడా చెప్తారు మీకు, ఎందుకంటే ఇవి లేకుండా మనం ప్రాబ్లమ్ సాల్వ్ చేయలేం. ప్రాపర్టీస్ లో కూడా ప్రతిదీ మనకు ప్రీవియస్ గా డిపెండ్ అయి ఉంటుంది. ఇక్కడ అన్నిటికీ మనకు మల్టిప్లికేషన్ థీరం, బేస్ థీరమే బేస్. మనం ఇంతవరకు మనం డెన్సిటీ ఫంక్షన్ కానీ, డిస్ట్రిబ్యూషన్ కానీ, కండిషనల్ డెన్సిటీ కానీ, మార్జినల్ డెన్సిటీస్ కానీ, ఇవన్నీ మనం ఎక్కడి నుంచి డ్రా చేసాం? బేస్డ్ ఆన్ మల్టిప్లికేషన్ థీరం ఓన్లీ. అందుకని ప్రతిదీ అక్కడ నుంచే బేస్. ఒకటి ఏంటంటే మనం ఇక్కడ ర్యాండమ్ వేరియబుల్ గురించి మాట్లాడతాం కాబట్టి ప్రాపర్టీస్ కూడా సేమ్ అదే వ్యాలిడ్ అవుతాయి మనకు. అందువల్ల మీరు ఆ కాన్సెప్ట్ అట్లే క్యారీ ఫార్వర్డ్ చేసుకుంటూ వెళ్తే మనకి ఈ కాన్సెప్ట్స్ అన్ని చాలా ఈజీగా అర్థమైపోతాయి. ఓకే,
థ్యాంక్ యూ సార్.
Okay, sir.
థ్యాంక్ యూ సార్. స్పెండింగ్ లాట్ ఆఫ్ టైం.
ఓకే సార్.
చాలా స్లోగా మంచిగా నీట్ గా ఇస్తుంది మీకు. థ్యాంక్ యూ సార్. హ్యావ్ నైస్.
అంత స్లోగా ఇస్తే వాళ్ళకి అంత నీట్ గా అర్థమవుతుంది అనేది అంత ఆశ, అంత ఇంకేం లేదు.
అవునవును సార్, హడావుడిగా చెప్పుకునే బదులు
హడావిడిగా చెప్పుకునే బదులు అంటే సిలబస్ నేను ఫాస్ట్ గా కంప్లీట్ చేసేయచ్చు. ఓన్లీ మనం ప్రీవియస్ క్వశ్చన్స్ అన్ని రేపు సార్, నేను రేపు వీళ్ళకి గేట్ ఎగ్జామ్ లో ఎలాంటి క్వశ్చన్స్ అడతారో కూడా చెప్తాను.
వీటి మీదనా సార్?
ఇంతవరకు అంతా సిఎస్ఐఆర్ క్వశ్చన్ వీటి మీదనే. ఇంతకు ముందు అంతా సిఎస్ఐఆర్ క్వశ్చన్స్ ఉన్నాయి కదా, రేపు గేట్ క్వశ్చన్స్ ఎట్లా ఉంటాయి సేమ్ ఇదే టాపిక్ మీద
సెట్
మనం
కూడా
ఎలా సాల్వ్ చేయాలి గేట్ క్వశ్చన్స్.
కొన్ని క్వశ్చన్స్ సెట్ కూడా తీసుకోండి సార్ ప్రీవియస్ లో, అందుకే మన వాళ్ళకు కొంచెం వస్తుంది.
ఓకే ఓకే,
నా దగ్గర ఒక 2 పేపర్ ఏపీ సెట్, టీఏ సెట్ ఆన్లైన్ లో కూడా ఉన్నాయి సార్, వెబ్సైట్ లో మీకు కూడా పంపిస్తాము.
నేను చూస్తాను సార్ ఒకసారి. చూస్తాను సార్, నా దగ్గర ఉంటే నేను వెతుకుతాను, దాని ప్రాబ్లం లేదు.
వాళ్ళు ఇంకా కొంచెం తరువు అవుతారు.
ఓకే ఓకే, ఎందుకంటే క్వశ్చన్ ప్యాటర్న్ అంతా సేమ్ ఒకటిగానే ఉంటది. ఎవ్రీ సిచ్యువేషన్ మనకి ఎలా అంటే సేమ్ క్వశ్చన్ అయితే మనం ఎక్స్పెక్ట్ చేయకూడదు, ఎందుకంటే మనకు ప్రతి దాంట్లో క్వశ్చన్ డిఫరెంట్ గా ఉంటది. ఎందుకంటే మేము కూడా అంటే పర్సనల్ గా నేను కూడా వెళ్తాను, అంటే యూపీఎస్సీ లో క్వశ్చన్ పేపర్ సెట్టింగ్కి వెళ్తాం కదా, ఒక క్వశ్చన్ మళ్ళీ రిపీట్ అవ్వకూడదు అనమాట. అలా ఉంటుంది ఆ రూల్. ఒక క్వశ్చన్ మళ్ళీ రిపీట్ అవ్వకూడదు, ప్యాటర్న్ రిపీట్ అవ్వచ్చు కానీ క్వశ్చన్ రిపీట్ అవ్వకూడదు ఎప్పటికీ. తర్వాత ఇది కూడా మేము ఆలోచిస్తాం, ఎంత టైంలోనో వీళ్ళు క్రాక్ చేయగలరు ఆ క్వశ్చన్. ఇప్పుడు నేను ఎక్స్పీరియన్స్ ఉంది కాబట్టి చాలా ఫాస్ట్ గా చేయగలను, కానీ స్టూడెంట్ పాయింట్ ఆఫ్ వ్యూ లో మనం ఎంత తొందరగా క్వశ్చన్ క్రాక్ చేయగలరు అనే దాన్ని బేస్ చేసుకొని క్వశ్చన్ ప్రిపేర్ చేయాల్సి ఉంటుంది మాకు. సో అలాంటిది ఇస్తారన్నమాట టాస్క్.
ఈ మధ్యన సార్ ఇంకొకటి సార్, ఈ మధ్యన ఇచ్చే పేపర్ సెట్టింగ్ కూడా స్టేట్ లెవెల్ ఎలిజిబిలిటీ టెస్ట్ కూడా ఎన్టీఏ నుంచి వస్తున్నట్టు ఉంది సార్. పేపర్ సెట్టింగ్ చూసినా, అప్రోచ్ చూసినా కూడా.
అవునండి, ఎన్టీఏ అంటే క్వశ్చన్స్ అన్ని వాళ్ళు ఏమైనా డిస్క్లోజ్ చేయరు, కానీ ద ఎక్స్పర్ట్స్, మనం ఎవరైతే ఎక్స్పర్ట్ వీళ్ళు క్వశ్చన్ పేపర్ రెడీ చేస్తారో వాళ్ళు మీరు కన్ఫామ్ గా ఐఐటి ఎన్ఐటి నుంచి ఎక్స్పెక్ట్ చేయొచ్చు అనమాట. వాళ్ళే క్వశ్చన్ పేపర్ సెట్ చేస్తారు జనరల్ గా చెప్పాలంటే.
అవును సార్, అలానే ఉన్నాయి.
అందువల్ల డెప్త్ ఎక్కువ ఉంటది క్వశ్చన్ పేపర్ లోని క్వశ్చన్స్ అన్ని డెప్త్ ఎక్కువ ఉంటది. ఇది స్టాటిస్టిక్స్ కాబట్టి ఇంకా లైట్ గా అడుగుతున్నారు. చాలా చెప్పాలంటే చాలా లైట్ క్వశ్చన్స్ ఇవన్నీ. అదే మ్యాథమెటిక్స్ తీసుకోండి, ఎంత డెప్త్ అంటే కనీసం మనం ఓన్ లేదన్నా ఒక క్వశ్చన్ కి ఒక 5 to 7 minutes మనం అర్థం చేసుకోవడానికి టైం పడుతుంది. ఆన్సర్ వేరే విషయం, దేవుడు ఎరుగుతారు.
థ్యాంక్ యూ సార్.